Explorer 1 and Explorer 2 were exceptional spacecraft. Far from being regular models, they were meticulously engineered with durable structures and a rotation speed considerably slower than the hour hand of a clock, multiple times over. This design feature reduced visible blurring, allowing the spacecraft to capture both pictures and data simultaneously as they traversed the vastness of space. Even before their missions took them to the outer planets, their remarkable imaging technology had already begun to impress both scientists and the public. The spacecraft began transmitting images of Jupiter months ahead of completing their primary objectives. These early pictures, showing swirling clouds and the renowned Great Red Spot, captivated audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Slightly larger than Earth's moon, Io turned out to be the most volcanically active body in the entire solar system. The spacecraft's instruments detected constant activity from Io, which was confirmed by the vibrant images showing towering volcanic eruptions and a surface marked by volcanic deposits. One of Io's most notable volcanoes, Pele, erupted with a force many times stronger than Mount Everest, covering an area nearly the size of France. Eventually, as the spacecraft's cameras powered down to preserve energy and memory before their journey into interstellar space, it is important to note that the photos they captured did not include Mercury or Mars for several reasons. Despite this, NASA continued to develop other remarkable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Explorer 1 surpassed Pioneer 10, marking the moment when Pioneer 10 was outpaced as the farthest spacecraft. Explorer 1 continued its solitary voyage for another 14 years, eventually entering the interstellar medium on August 25, 2012. Although there were no new extraordinary space missions on the horizon, NASA did not publicly announce this major achievement until 2013. The S8 strain emerged due to gravitational lensing studies, which suggested a lower-than-expected value for S8 based on data from the Cosmic Microwave Background, CMB. Research aimed at resolving the S8 anomaly has led scientists to examine a variety of theories, from potential data errors to fundamental shifts in our understanding of gravity. Contemporary simulations, like the Flamingo project, have been essential in offering insights into the complex interplay between dark matter and gravitational forces in shaping the cosmic web. Despite the challenges posed by the S8 strain, many measurements at low redshifts and from the CMB remain consistent with the standard cosmological model. This has led to exciting speculation that the universe may have undergone significant changes, pushing us to reconsider our current theories about the large-scale structure and evolution of the cosmos. In short, the S8 strain poses a major challenge to our understanding of cosmological structures and may necessitate updates to our existing theoretical frameworks. Explorer 1 continues its extraordinary journey, faithfully sending back invaluable data from the furthest reaches of the universe for nearly 5 decades. This unprecedented spacecraft has dramatically transformed our knowledge of space. Yet, in recent years, Explorer 1 has begun transmitting strange data back to Earth, leaving the entire space agency stunned. Are these unsettling signals the result of a malfunction, or could they be messages from extraterrestrial sources? Join us as we investigate the truth behind these astonishing transmissions. For centuries, scientists have been fascinated by the unknowns that lie beyond our planetary boundaries. This curiosity led to the extraordinary launch of Explorer 1 and Explorer 2, among other prestigious space missions. These groundbreaking missions, celebrated for their accomplishments, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. A few months later, on September 5, 1977, Explorer 1 was launched. These twin spacecraft, each weighing approximately 710 kilograms, roughly equivalent to a small car, were sent into space during a specific alignment of the outer planets, marking the beginning of their remarkable journeys. The explorers traveled in different directions at varying speeds, culminating in a defining moment on December 15, 1977, when Explorer 1 surpassed its twin. Since then, Explorer 1 has evolved into an indispensable tool, providing vast amounts of data and unraveling the secrets of space. Before diving into Explorer 1's most recent shocking discovery, which has profoundly amazed the entire space agency. Let's first explore the spacecraft's incredible contributions, particularly its Jovian imaging mission. In 1978, Explorer 1 was positioned about 265 million kilometers from Earth. From this vantage point, it began transmitting a wide range of images back to Earth. In January 1979, the shuttle embarked on a 100-hour mission, capturing time-lapse photos of Jupiter's rotation. This treasure trove of 3,750 images allowed scientists to observe Jupiter's dynamic movements in remarkable detail. Soon after, Explorer 1 made its way through the Jovian moon system and made a significant discovery: a small ring around Jupiter and new moons, Thebe and Métis. This expanded our knowledge of Jupiter's intriguing environment. To ensure a safe trajectory and avoid a potential collision with Titan, one of Saturn's moons, the spacecraft executed corrective maneuvers. Explorer 1 then continued its celestial journey towards Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. After completing its Saturn mission, researchers decided to end the planetary objectives of the Explorer mission and directed both Explorer 1 and Explorer 2 beyond the Sun's influence, speeding through space at an extraordinary pace of 325 million miles each year. In January 1990, a new phase began, the Explorer Interstellar mission. During this period, Explorer 1 captured some of the most iconic images in history, immortalizing the solar system and most of its planets. One key figure in extending the mission's objectives beyond their original scope was renowned astronomer Carl Sagan. As a member of the Explorer imaging team, Sagan passionately advocated for one final set of images as a parting gift to humanity. Against all odds, his tireless effort succeeded, and on February 14, 1990, Explorer 1, positioned 6 billion kilometers from Earth, captured the famous pale blue image. These breathtaking images, totaling 60, were added to the spacecraft's impressive portfolio of 670 photos taken during its encounter with Neptune. Explorer 2, during its journey, made a notable achievement in recording wind speeds of over 1,000 meters per second, the highest ever observed in the solar system. As it ventured 298 kilometers into Neptune's methane atmosphere, it provided groundbreaking insights into this faraway planet. Neptune's largest moon, Triton, was identified as one of the coldest places in the solar system, with surface temperatures plummeting to extreme lows. Triton also displayed extraordinary features such as nitrogen gas geysers and ice volcanoes that expelled debris up to 5 miles into its thin atmosphere. These remarkable discoveries expanded our understanding of the diverse and complex celestial bodies that populate the farthest corners of our solar system. Recently, Explorer 1 has made one of its most alarming discoveries. Before diving into this new, unsettling finding, let's reflect on the spacecraft's vast accomplishments. The early observations of Jupiter and Saturn's moons left scientists in awe and challenged previous assumptions about these distant worlds. Moons once considered barren and dormant, like our own moon, were found to be rich in geological activity. Explorer 2, in particular, made several history-making feats during its journey. In 1986, it became the first spacecraft to fly past Uranus, and just 3 years later, it performed a flyby of Neptune, becoming the only spacecraft to achieve such feats. As the Explorer spacecraft continued their missions, NASA implemented various strategies to extend their operational lifespans. Over the past 3 years, certain components and radiators have been deactivated to conserve power, ensuring that these bold explorers can continue their work well into the next decade. The projected mission end date is set for 2030. For the researchers and specialists who have been involved from the beginning, the Explorer missions represent both a source of immense pride and a wave of nostalgia. Their relentless efforts have far exceeded expectations, and the wealth of data provided by the spacecraft has led to countless scientific discoveries, inspiring both researchers and space enthusiasts alike. Explorer 1 and Explorer 2 were not just ordinary spacecraft. They were the result of careful planning, robust designs, and rotation speeds many times slower than the hour hand of a clock. This innovative configuration minimized visible blurring, allowing the spacecraft to capture data and images simultaneously as they traveled through space. Even before their interactions with the outer planets, their exceptional imaging capabilities began to captivate researchers and the public. The spacecraft began transmitting images of Jupiter long before completing their primary missions. These early images, showcasing swirling clouds and the famous Great Red Spot, captivated audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly seized the spotlight. Slightly larger than Earth's moon, Io turned out to be the most volcanically active object in our solar system. The spacecraft's instruments detected consistent signals from Io, which were confirmed by the vibrant images they transmitted, revealing volcanic plumes and a surface scarred by volcanic eruptions. One of Io's most significant volcanoes, Pele, erupted with an intensity many times greater than Mount Everest, covering an area nearly the size of France. Eventually, the spacecraft's cameras powered down to conserve energy and memory before their journey into the interstellar medium. It's important to note that the images they captured did not include Mercury or Mars for several reasons. Nevertheless, alongside Explorer 1 and Explorer 2, NASA has also launched other impressive spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Explorer 1 overtook Pioneer 10, becoming the most distant spacecraft. Explorer 1 continued its solitary journey for another 14 years before entering the interstellar medium on August 25, 2012. Although no major space missions followed, NASA did not publicly announce this significant milestone until 2013. The discovery of the S8 strain, emerging from gravitational lensing studies, suggested a lower-than-expected value of S8 based on data from the Cosmic Microwave Background, CMB. The exploration of this anomaly has led scientists to consider several theories, ranging from data errors to major shifts in our understanding of gravity. Current simulations, like the Flamingo project, play a critical role in offering insights into the interactions between dark matter and gravity in shaping the universe's structure. Despite the challenges presented by the S8 anomaly, most low redshift measurements and CMB data still align with the standard cosmological model. This has prompted the exciting possibility that the universe may have experienced significant changes, challenging our understanding of the cosmos's evolution. In conclusion, the S8 strain poses a major challenge to our theories of cosmological structure and may require updates to our existing frameworks. Explorer 1 and Explorer 2 represent the pinnacle of human ingenuity, launched with a vision to uncover the mysteries of our solar system and beyond. These remarkable spacecraft continue to inspire researchers and astronomers, even decades after their initial missions began. Their scientific contributions not only reshaped our understanding of planetary bodies, but also propelled space exploration to unprecedented heights. Throughout their missions, the data they returned provided invaluable insights that have guided subsequent space missions and technological developments. One of the most extraordinary aspects of the Explorer spacecraft missions was their longevity and durability. Designed to withstand the harsh environment of space, both Explorer 1 and Explorer 2 demonstrated exceptional resilience. For many years, they withstood extreme temperatures, cosmic radiation, and the vacuum of space. Their imaging technology, in particular, proved to be revolutionary, allowing scientists to capture detailed images of distant planets and moons. These spacecraft's remarkable ability to relay data from millions of kilometers away provided a deeper understanding of planetary geology, atmospheres, and magnetic fields. Explorer 1's incredible ability to detect cosmic rays and its pioneering work in studying the Earth's radiation belts was a crucial moment in the history of space exploration. Prior to this, scientists could only speculate about the composition and behavior of the space environment. With its sensitive instruments, Explorer 1 provided direct measurements, laying the foundation for future missions focused on space weather and cosmic radiation. The discovery of Earth's radiation belts, later named the Van Allen belts, became one of the most significant breakthroughs of the 20th century in space science. Both Explorer 1 and Explorer 2 demonstrated the effectiveness of NASA's innovative engineering and mission planning. These spacecraft were crafted with the utmost precision to ensure that every component worked in harmony to collect data across vast distances. The spacecraft's ability to execute course corrections, adjust to the changing gravitational influences of the planets, and respond to the intense radiation environment of deep space made them adaptable tools capable of performing a range of scientific tasks. Their extensive mission profiles, which spanned from studying planetary systems to exploring the outer limits of the solar system, showed that no mission objective was too complex for these highly sophisticated spacecraft. While the missions focused primarily on planetary exploration, their discoveries extended to a range of other scientific fields. The analysis of magnetic fields, the study of planetary atmospheres, and the observation of solar phenomena offered new perspectives on the workings of our solar system. In particular, the study of planetary magnetospheres and the interaction of solar wind with planets' magnetic fields helped scientists understand the conditions that make Earth habitable. Explorer 1's measurements of charged particles in Jupiter's magnetosphere, for example, helped refine our understanding of how the giant gas planets' magnetic fields interact with their moons and surrounding space environments. In addition to their technical feats, Explorer 1 and Explorer 2 contributed significantly to expanding our knowledge of extraterrestrial life. While the idea of alien civilizations remained speculative for many years, the data returned by these spacecraft, including atmospheric analysis and surface composition studies, laid the groundwork for future missions searching for signs of life beyond Earth. The prospect of discovering life on other planets or moons became an increasingly central theme in the pursuit of space exploration, and both Explorer missions highlighted the importance of understanding the potential for life in extreme environments, such as on the icy moon Europa or in the methane-rich atmosphere of Titan. The curiosity and excitement that followed the transmission of the first images of distant moons, planets, and stars ignited a sense of wonder that transcended the scientific community. These spacecraft were not only technical marvels, but also symbols of humanity's collective drive to explore the unknown. Their images inspired countless individuals to pursue careers in science and engineering, and they played a pivotal role in shaping the public's fascination with space exploration. This shared sense of discovery fostered a global appreciation for space science and technology, with scientists, educators, and enthusiasts coming together to celebrate the achievements of these spacecraft. As Explorer 1 and Explorer 2 journeyed farther into space, their missions began to evolve in response to the changing landscape of space exploration. The focus shifted from planetary exploration to studying the broader universe. As they moved into interstellar space, the spacecraft took on new roles in investigating the cosmic radiation environment and studying the magnetic fields of the interstellar medium. This phase of the mission brought new scientific challenges and opportunities, as both spacecraft began to encounter regions of space never before explored by humanity. The most recent anomaly transmitted by Explorer 1 has prompted a renewed sense of urgency and intrigue in the scientific community. Some have suggested that these strange signals might be the result of unknown cosmic phenomena, possibly linked to previously undiscovered particles or forces. Others have pointed to the possibility that the spacecraft's instruments might have encountered regions of space where the laws of physics behave differently, providing new opportunities for research. These uncharted territories open the door for potential discoveries that could revolutionize our understanding of the cosmos. Despite the ongoing speculation about the true nature of these signals, the scientific consensus remains cautious. The data could indicate new discoveries related to dark matter, dark energy, or unexplained cosmic forces that have yet to be fully understood. With the development of advanced technologies and new techniques for data analysis, scientists continue to probe these anomalies, hoping to unlock the secrets hidden within them. Whether they lead to groundbreaking revelations or are ultimately explained by more mundane causes, the exploration of these signals promises to add another layer of intrigue to the already rich legacy of the Explorer spacecraft missions. Ultimately, the story of Explorer 1 and Explorer 2 is a testament to the enduring spirit of exploration and discovery. These spacecraft, which have traveled farther than most objects ever created by humankind, continue to push the boundaries of our understanding of the universe. From their groundbreaking discoveries of planetary moons and magnetic fields to their ongoing mission into interstellar space, the contributions of these spacecraft will be felt for generations to come. As we look toward the future of space exploration, the legacy of the Explorer missions serves as an enduring reminder that humanity's quest for knowledge has no bounds, and that the mysteries of the universe are always within reach for those brave enough to seek them.